So as with many things in math, there are different ways to solve the same problem. So I'm going to show two different ways to solve this system of equations here. So looking at the first equation, see how it's got y's, x's equals a number? That's set up pretty well for elimination. But the second equation is y equals by itself, which is good for substitution or for graphing. So I'm going to use substitution here. I'm going to take the 3x plus 8, which is equal to y. I'm going to substitute that in where y is in the first equation using parentheses. Again, this is substitution. So negative 4 times the y thing plus 6x equals negative 8. Then I'm going to distribute the negative 4 into our parentheses. We get negative 12x minus 32 plus 6x equals negative 8. Combining like terms, negative 6x minus 32 equals negative 8. Two-step from here. So 24 equals negative 6x. So dividing by negative 6 gives us x equals negative 4. As always, we've got to find the y as well. So we're going to take negative 4, plug it back in where x is to find y. So y equaling 3 times negative 4 plus 8 would be negative 12 plus 8, which is actually also negative 4. So our solution using substitution here is negative 4, negative 4. I'm also going to graph both lines over here on the grid. So the second equation has a y-intercept of 8 and a slope of 3. So that means start at positive 8 and go up 3 over 1, because 3 is really 3 over 1, rise over run. So we run out of space pretty quickly here, following it up and right. So up 3, right 1 runs out of space right here. So we're going to follow this pattern backwards. Instead of up 3, right 1, that's the same thing as down 3, left 1, by following the pattern backwards. So from 8, we're going to go down 3, left 1, down 3, left 1, and just keep following that pattern backwards to complete some more coordinates on this grid. Now I'm going to use my straight edge. I'm going to connect through these to make the line. I'm going to label it y equals 3x plus 8. Okay, for the other equation, we've got to get into y equals form first. It's not y by itself yet. So I've got to take negative 4y plus 6x equal to negative 8 and get y by itself. I'll move the x's first by subtracting. So we get negative 4y equals negative 8 minus 6x. And then to get y by itself here, I'll bring that back. To get y by itself, we want to divide every single piece by negative 4. So we get y equals 2, and then a negative over negative is a plus, so plus 3 over 2x. If we just reduce that 6 over 4 down, same thing as 3 over 2. 6 over 4 is fine too. So starting at a 2 here on the y-axis, positive 2, I'm going to go up 3 over 2, up 3 over 2 to the right, like this, and then following it backwards, down 3, left 2, down 3, left 2, down 3, left 2, down 3, left 2. That makes the second line here. Again, using a straight edge, going to connect those, arrows on the ends, and label that with the equation 2 plus 3 over 2x. So the solution is where they intersect, which is right here, which we already knew because that's at negative 4, like we said, using substitution. So two different methods there to show the solution is negative 4, negative 4. For the next one here, I'm going to use substitution and elimination for this one. So this right here, 2y plus 20 is equal to x. I'm going to plug that in for x in the second equation. So we're going to do 4 times the x thing plus 1y equal to 8. So that would be, so that's 8y plus 80 plus 1y equals 8. And then that would be 9y plus 80 equals 8. And then continuing here, so if I subtract 80 from both sides, This would be negative 72 equaling 9y divided by 9, y equals negative 8. Then to find the x, we're going to do x equals 2y plus 20. So x equals 2 times the y plus 20 is negative 16 plus 20, which is 4. So that's 4, negative 8 is our solution using substitution. I'm just going to slide this over here as our first method. So the substitution method. For elimination, I want to get them both in this form, 4x plus 1y equals 8, where it's x's, y's equals numbers. So just the first one, we got to get over into that form. So x equals 2y plus 20. I want to get the y's to the other side. So that would be x minus 2y equals 20 by just subtracting the two y's from both sides. I'm going to bring the other equation down. And now we're all lined up. Now we just need opposites. I can do that by doing times 2 to the bottom. So that would be 8x plus 2y equals 16. And the top one I'm going to keep the same. And now I've got opposites. I can just add them. The y's cancel. I get 9x equals 36. Divide by 9. X equals 4. And then I've got to just plug back in to get y once I've got the x coordinate. So either equation is fine. I'm going to use the second one. So 4 times 4 plus y equals 8. So 16 plus y equals 8 minus 16 from both sides gives us y equaling negative 8, which we already knew from the previous way we did it. But the whole idea was solving it either way will always give us the same solution as long as you don't make a mistake. So this is the elimination method on the right and the substitution method on the left. Either way is going to work. Graphing will also work as well. Just sometimes there's one method that works a little bit easier than another method, but it's kind of personal preference as well.